Hey students, so the next topic is how to count atoms in a chemical formula. Okay, so here are the steps. So write the chemical formula, list all the atoms, count the number of atoms of each element in one molecule, which is subscript, multiply the number of atoms by the coefficient, double check your answer to ensure every atom is accounted for. So basically, find the element, like look at the capital letters to see which elements are in the formula. Okay, the next step is check the subscript. Subscript means small numbers. This tells you how many of that atom are in one molecule. If there is no number, it means one. Okay, and multiply by the coefficients, which is big front numbers. If there is a big number at the very front, multiply every atom count by that number. Okay, so we have to do activity, then you will understand it. Okay, so this is 6C2H5OH, which is ethanol. Okay, so the correct way is this: 6C2H5OH, which is 2 and H are small numbers. Okay, so C is carbon atom, H is hydrogen, O is oxygen, and also this H is hydrogen. Okay, so the big coefficient is 6, this one. Okay, which means we multiply everything by 6. Okay, like 2, this 5 and this H combines together to form 6. Okay, so there are 2 carbons in the molecule, which is C2, means 2 carbon atoms in the molecule. Okay, so you have to multiply 2 into 6, which is this 12. Okay, and see this hydrogen and this hydrogen means 6. Okay, we have 5 hydrogen atom in this and also this, which means total hydrogen atoms are 6. Okay, then you have to multiply this with 6, which is equals to 36. Okay, so there is no subscript for this oxygen, O. Okay, which means 1. So you have to multiply 1 with 6. This. Okay. So this is the correct way to count atoms in a chemical formula. Okay. So the next one is activity. Okay. How many atoms? This. So the first one is sodium hypochlorite. Okay. Look at this carefully. You see that no big coefficient in front means we are just looking at one molecule. Okay. Na. Okay, let's break it. Na means sodium, Cl means chlorine, and O means oxygen. Okay, so Na has one atom, Cl has one atom, and oxygen O also has one atom, because no big coefficient in front means we are just looking at one molecule. Okay, so the total number of atoms are 1 plus 1 plus 1, which is 3. Okay, so the next one is, okay, let's, so the next one is ammonia. Okay, which is the correct way to write is 4 N H and 3 is small. Okay, so what is the big coefficient? Yes, this 4. The big coefficient is 4, so multiply everything by 4. Okay? Like nitrogen. 1 multiplied by 4 is 4. This is nitrogen. Okay? Hydrogen. Hydrogen has, yes, 3. So you have to multiply 3 multiply by 4. And why we multiply with 4? Because this big coefficient, we multiply everything with this 4. Okay? 3 fours are 12. And total number of atoms are, like, you have to sum all these answers. Total is 4 plus 12. Okay? So the answer is 16 atoms. Okay? Okay, so the next one is hydrazine. And the correct way to write it is 8N2H4. Okay? Okay. So the process is same like the things we discussed in the previous activities. Like the big coefficient is 8. Okay? So multiply everything by 8. Like nitrogen N2 have 2 atoms, mean that you have to multiply this 2 with 8. Okay? And hydrogen have 4, which have multiply by 8. Okay? And at the end, you have to count all the atoms. Okay? Then we will know the total number of atoms. Okay? Okay, student, this is your self-assessment and you have to do this with your own self. Like you have to count the total number of atoms. The things we discussed in the previous activity, you have to apply the same method in this. I wrote the correct version of this. 2 C7 H5 NO3. Okay, students? So first you look at the big coefficient, which is 2, and you have to multiply all the things with this 2. Okay, like 7 multiply by 2, 5 multiply by 2, 3 multiply by 2. And the correct answer is when you multiply all the things with the 2, then you have to sum up the total number of atoms, which is like 7 into 2, which is 14, 5 into 2, which is 10, 1 into 2, which is 2, and also O, 3 into 2, this oxygen atom. Okay? 3 into 2, which is 6. Okay? Then you have to add all the answers by this, and then you will get the total number of atoms. Okay? So the next topic is counting atoms and molecules in a chemical equation. Okay. So basically, a chemical equation has two main parts. Okay? This one, you can say reactants, and this one, which is product. So left side is reactant, like what you start with, and the right side is product, like what you make. Okay, and the rule is that the total number of atoms for each element must be exactly the same on both sides. Okay, like the total number of atoms must be same on both sides. Okay, students? So, so steps. Count the number of atoms in each reactant and count the number of atoms in each product. Like you have to count the number of atoms in reactant and product. The number of atoms in the reactant should equal the number of atoms in the product. Okay, let's look at this example. 4FeS plus 7O2 is equal to 2Fe2O3 plus 4SO2. So basically, Fe is iron, okay? S is sulfur, O is oxygen, okay? So look at the left side, 4FeS, okay? And we have a big number is 4, okay? So one atom, as you guys can see that it don't have any small numbers, so it means that it have one atom. So one atom multiplied by big, no, a big front coefficient, you can say, which is 4. So 1 multiplied by 4 is 4, okay? And the right side is this. Look at this, Fe, which is it have two small number and one big number, which is coefficient. So you have to multiply this with this, 2 into 2, which is 4. It means the reactant have 4Fe and also the product have 4Fe, okay? Which means that the reactant side of iron is equal to product side of iron, okay? 4 is equals to 4, match. Okay, so the next one is sulfur. Left side is 4FeS. As you guys can see that sulfur don't have any small number, it means it have 1. So it have one atom. So 1 into 4 means 4. Okay, like you can write for understanding the one small s in this. Okay, so right side, where is right side? Yes, this one. Okay, 4SO2. As you guys can see that S don't have any small number. So you can write 1 for understanding, which means that when a number don't have any small number, it means that it have one atom. Okay, so you can multiply small number with the coefficient big number, which is 4. Okay, 4 is equals to 4. Yes, match. So the next one is oxygen. Okay, oxygen is in two different places on the right side, so we add them together. Okay, 7O2 means 7 is a big coefficient number and 2 is a small number. So the rule is that you have to multiply small to coefficient, which is 7 times 2 is 14. Okay, okay, so look at the right side. 2Fe2O3 plus 4SO2. As I have told you that oxygen is in two different places on the right side, so we add them together. Okay, from the first part, 3 atoms multiplied by big front number, which is 3 atoms, and big front is 2. So 3 times 2 is 6. Okay, this. Okay, sorry. Okay, and from the second part, like, look at this. Yes, 2 oxygen atoms and 4 is a big coefficient number. So you have to multiply these two. Okay, 4 into 2, which is 8. Okay, so the total number is you have to add this 8 with this. Okay, which means 40. So we have balanced equation. Like oxygen atom is 14 in the reactant side and also in the product side. Okay. So I think you can do this activity very well. So activity is count the number of atoms. Okay. 2H2 plus O2 is equals to 2H2O. Okay. Look at the left side. Yes. 2 big. This 2 is small. Okay. This 2 is small, and also this 2 is small. Okay. Left side, hydrogen. Look at the hydrogen, which is H. Too big plus too small. Too big means that this coefficient is big and this is small. So you have to multiply 2 into 2, this is 4. Okay, plus O2. Left side, you guys can see in the oxygen, it don't have any big coefficient. So no big number multiply by 2, which is 2. Like 1 into 2 is 2, which means 4 hydrogen and 2 oxygen. And the next one is 2H2O. Yes, this is a big number and this is a small number. So you have to multiply both, which means 2 cross 2 is 4 and O is lonely. Okay? 2H2 plus O2 is equals to 2H2O. Both sides have 4 hydrogen and 2 oxygen and it matches. Okay? So I I will tell you the answer of the next two and you have to identify how. Okay? So the next one is CH4 plus 2O2 is equal to CO2 plus 2H2O. So you have to do this activity on your own and the answer is that both sides have 1 carbon, 4 hydrogen and 4 oxygen. Okay? You have to follow the same process and then you will calculate easily. Okay. So the next one is NaClO plus NH3 is equal to H2O plus NaCl N2H4. Okay. So we have the total is so students, this equation actually does not match. It is unbalanced equation. Like the left side has 1 nitrogen and 3 hydrogen, but the right side has 2 nitrogen and 6 hydrogen. Okay? So you have to do this activity on your own. Okay. The next one is calculate the amount of reactant on products in a chemical equation. Okay. If we know how many atoms are in the reactants, we can solve how many atoms are in the products. Similarly, if we know how many atoms are in the product, we can easily calculate how many atoms are in the reactants. Okay. For example, okay, let's take this example. It is easy so that you can understand it easily. Okay. So the example is 6H2O plus 3O2. Okay, like you have to make the product side. Okay. So count what you have on the left side. So as I have told you that we simply multiply this with this, which means we have 12 hydrogen atoms. Okay. And oxygen is simple 1 in this, which means 1 multiplied by 6 is 6. Yes, 6 hydrogen. And also we have another oxygen atom, which means you have to multiply this with this. 3 multiplied by 2 is, yes, 6. Or 2 multiplied by 3 is 6 also. Okay. So it means the total oxygen, like we have this oxygen atom and this oxygen atom, like its value is 6 and it's also 6. So we can simple combine this. 6 plus 6 is 12, which means we have 12 oxygen atoms in the reactant side and 12 hydrogen atoms in the reactant side. Okay, so figure out the missing front number. Okay, like we need to make H2 and O2. Okay, like hydrogen free oxide. Each single package needs 2H and 2O. Okay, since we have 12 hydrogens and 12 oxygen total. Okay, so we simply divide it by 2. 12 divided by 2, which is 6. Okay, so the full balance equation is H, like we simple make H2O2, but the number we required is 6. Okay, 6 H2O2. Okay, let's do another example so you can understand it more easily. Okay, so the next one is 6C 284. Like you have to make this, okay, plus 6H2O. Okay, how many C2H6O? Okay, so in simple, count what you have on the left side. Yes, carbon. Carbon is 12. How? Because the coefficient is 6 and small number is 2, so we simply multiply it. And also hydrogen, H4. We simply multiply this with this. 6 into 4, 24 hydrogen. Okay. And also this 6H2, which is 12. And how many oxygen atom? Yeah, 6. And one thing to notice that we have hydrogen in this and hydrogen in this. So we simply add these values so that we can have total number of hydrogen in this. 24 plus 12 is, yes, 36. Okay, so we simply have 36 hydrogen. Wait. We simply have 36 hydrogen, 6 oxygen, and 12 carbon. Okay, so figure out the missing front number. Okay, wait, I have to remove this. Like C2H6O we require. Okay, we need to make C2H6O, which is this. Okay, students? So look at just carbon to make it easy. Each package needs 2 carbon atoms. We have 12 carbon atoms total. Okay, so we simply add 12 by 2, which is 6. Means 6 C2H6O. Okay, students? Like we need to make C2H6O and look at just carbon to make it easy. Each package needs 2 carbon atoms. Okay? So we have to make 12 carbon atoms total divided by 2. So the next one is, okay, these are small. Okay, 12H2 plus 6O2. Okay, how many H2O? Okay, like in the previous example, like 12 is a coefficient and 2 is a small number. So we simply multiply this. 24 hydrogen. Okay, and how many oxygen atom? Yes, 12. How many H2O? Okay, look, figure out the missing front number. So we need to make H2O, which is this. Okay, fine. Look at oxygen. Each package needs one oxygen atom. Okay, we need one oxygen atom. So we have 12 oxygen. Okay, so simple 12 divided by 1, which is 12. Okay, students? Like, you simply need, look at the product. Like, each package needs one oxygen atom. And we have 12. So we simple divide it by 1. Okay?